Hi everyone, welcome back to the episode 20 of Learning Kotlin Live. Did anything just change it? Change class and inheritance. Okay, that's where we stopped yesterday. Secondary constructors, creating instance of class, inheritance. Yeah, this is where we stopped yesterday. So let's take a look at inheritance here. So to declare an explicit supertype, we place the type after a colon in the class header. So this means that derived base P. Okay, base is a supertype of derived, and there's and the primary constructor of derived has a parameter p, which is an integer, and it inherits the constructor of base, which takes an integer. So yeah, if the derived class has a primary constructor, it means if it has a primary constructor declared there, and it must be initialized there using the parameters of the primary constructor. So maybe let's get back to where we were yesterday. Maybe let's see if we still have the code. Is that did I skip the problem? Did I? That's unknown, but anyway, let's get back to where we were yesterday first. So what? Why? That's a big question. Yeah, this is where we were. So it is not inheriting any class. So how about let's have an open class base, which has a default constructor, which also takes let's just call it B, and it inherits base. I think this is going to be a compile error because, yeah, this type has a constructor and thus must be initialized. So that's basically base P, I guess, according to, yeah, base P. Unresolved ref. So it's the noun here, reference. So here's what I'm wondering. What if there's a class, there's no default constructor for this class, or the default constructor takes no parameter. And let's see, how do we declare another constructor that takes p int and it implicitly what's that, delegate to the base class. So can we use this here, or it should always follow the base constructor? That's what I'm interested. Turns out no. Yeah, this primary constructor call is expected, so we can only call the primary constructor. That's very different from Java. That's interesting to me. So, wait, why? Primary constructor call expected? Okay, so it was actually talking about this. Really? We needed this? Oh, okay. It delegates to list. So I think it's actually possible to delegate to the integer, the one with integer here. Then it can delegate to any constructor. I mean, including any constructor of the super type. Yeah, so yeah, that's possible. So where were we? Inheritance. Declare an explicit supertype. We place a type after a colon in a class header. Yeah, we have already done that. If the class has no primary constructor, then each secondary constructor has to initialize a base type using the super keyword. So the constructor, we can have a constructor super here, wherever it is. Overriding methods. As we mentioned before, we stick to making things explicit in Kotlin, and unlike Java, Kotlin requires explicit modifiers for overridable members. We call them open and for override. So a function is not overridable if there's no open modifier. The override is required, yeah. If it was meaning, compiler would complain, yeah. There is no open like base declaring a method with the same signature in the server is illegal, okay? So we can still know what the functions are. I mean, maybe we can still know about the private functions by trying to overriding it illegally. That's no effect when added on members on the final class. A class with no open item. Okay, so I might not have mentioned this earlier, but this open class, this open modifier on this class also make it explicit that this class is inheritable. If you want to prohibit real overriding, so a member mark override itself is still open. So another derived from base, you can just add it to a final override. Then it is overridden from the base class, but it is still it is also not overridable anymore after that. After if there's a class that is derived from this another derived. Overriding properties. Overriding properties work in a similar way to overriding methods. So properties can be overridden too. This is also something that is very different from Java. Declared on a superclass that are then redeclared on a derived class must be prefaced with override. Open again, and they must have a compatible type. Compatible can be overridden by a property with an initializer or by a property with a getter method. With an initializer or by a property with a... Okay, so there's several ways that we can override it, and as long as the val here are the same. Really? You can also override a val property with a var property, but not vice versa. Uh, a val essentially has a getter, and overriding it as var additionally declares a setter. That's weird to me. Now that you can't use the override keyword as part of the property declaration in the primary constructor. Where is that okay, override constructor. Oh, really? So the constructor can be really? The constructor. Oh, okay. From the constructor, we will have a value or whatever, a parameter passed in, and it will be visible and during the init blocks. So these items can be overridden too. That's fascinating, and I don't know if it's worth the complexity. Derived class initialization order. During construction of a new instance of a derived class, a base class initialization is done as the first step, preceded only by the evaluation of the arguments for the base class constructor. Evaluation of the arguments of the base class constructor, and thus happen before the initial logic of the derived class is run. So let's just look at a sample here. So we have a base class and a derived class here. So how is this anything else? So in a function, it initializes a derived with hello world. So this is the function of the main, so this definitely comes before everything happens. And there is the derived class. And the derived class is later initialized. The base is always first initialized. So here we visit the init block println initializing base, and then this item where open value size integer equals to name.length. Also, I guess I haven't run into list yet, but I guess this means also run this statement when running that statement. Right, let's just take a look at it. Kotlin. Cause the specified function block with this value as its argument and return this value. So, okay. So it's going to pass length into this block and return the length itself there. So it's basically, I want to return this, but also pass this into the following block that I applied. So it says initializing size in base, and the size is 5. Why? Because it's the name.length, and the name.length is wow. So here's the constructor of the derived class, which takes the name that capitalized that also. So this delegates to what? Base? Okay. So it passes name to the base. So the name is hello. So here we're seeing initializing size and base 5. So after the initialization of the base class, we're going to initialize the derived class. So first of all, we're going to see the here we see the base, the derived constructor called somewhat. So first we see println initializing derived, which is here, and then we see this and initializing size in derived. Ta-da! Okay, so it's passing in the size, and because this size is overridden, so it is then overridden. So this time when we take the size, wow, this is not quite correct. I mean, this is not what we were expecting. It is not really taking whatever we want from size. It's actually putting this super dot size plus, which is later stored into size too. But this also means that this it here, it actually takes from this rather than size. But nevertheless, this is the sample that demonstrates how size changes from 5 to 10 after 2 phases, 2 rounds of initializations. By the time of the base class constructor execution, the properties declared or overridden in the derived class are not yet initialized. If any of those properties are used in the base class logic, it may lead to incorrect behavior or a runtime failure. So for this case, this actually kind of means that the only expected size of this derived hello world is actually 10. So this 5 is intermittent, which means just temporary. When designing a base class, you should therefore avoid using open members in the constructors, property initializers, and init blocks. So yeah, if it's open, this means that this 5 here is actually an arrow, which we would like to avoid. So calling the superclass implementation, code in a derived class can call its superclass functions and properties associated property accessors implementation using the super keyword. So this is also kinda unlike Java. Okay, we can call Java super anywhere when we want to in Java. Can we? I'm actually not 100% sure about that. Can we call any super from another function? Is that possible? I kind of have a feeling that it's not possible. I don't know. Let's take a look. Class, Java class. Java base class. What? What was that? Sublime style? So hi. I don't think there's a super dot. This super always means constructor. That's what I believe. Yeah, there's no such ability in Java. Yeah, this means constructor. Right. Wait a minute. I'm thinking of what I have experienced in Android. Oh, So yeah, there's a super dot high headhunter. HH means for hunter times hunter. So yeah, there's a super dot high there. So yeah, it's possible in Java as well, which I rarely do. So code in a derived class can call it super function, super keyword. So it's actually just like Java. There's an open function, so we can call it too. Yeah, and we can get that property as well. Inside an inner class, accessing the superclass of the outer class is done with the super keyword qualified with this outer class name. So this is kind of just like the blah blah dot list dot blah blah. That's what I believe. There's a bar and there's an inner class baz. So to access the f, we use the so in Java we use foo dot this dot f. So in Kotlin it's very like overriding rules. In Kotlin, implementation inheritance is regulated by the following rule. If a class inherit, whatever. If a class inherits many implementation, okay, let's first take a look at if there's any live chats. No. Okay, then let's move on. In Kotlin, implementation inheritance is regulated by the following rule. If a class inherits many implementations of the same member from its immediate superclasses, it must override this member and provide its own implementation. What? Why? What? So in Kotlin, you can, does that means that we can inherit multiple classes? Implementation inheritance is regulated by the following rule. If a class inherits many implementations of the same member from its immediate superclasses, many implementation of the same member from its immediate superclasses. So I think that means two F's. So yeah, interfaces are open by default. So if there are two F function implementations, then it must override F itself. To denote the supertype from which the inheritance is taken, we use super qualified. So there's a super left. What's the name of this? Triangle, angle brackets, super angle brackets, and A or B or whatever, then call it. It's fine to inherit from both A and B, and we have no problems with A, B, and C. Inherits only one implementation of each of these functions. A, B, or C. Where the heck is C? Oh, since C inherits only one, okay. But for F, we have two implementations. Yeah. Okay, that's a lot today. Abstract classes. A class and some of its members may be declared abstract. An abstract does not have an implementation in its class. Note that we do not need to annotate an abstract class or function with open. It goes without saying, of course. we can override a non-abstract number member with an abstract one. Override abstract function, of course. So companion objects in Kotlin, unlike Java or C# classes, do not have static methods. This is something new. But we already learned about the extensions. In most cases, it's recommended to simply use package level functions instead. Package level functions. So there are package level functions. Okay, that's cool. If you need to write a function that can be called without having a class instance but needs access to the so extensions are actually not static because they always have the instance itself. So if you need to write a function that can be called without having a class instance but needs access to the internal of a class, for example a factory, you can write it as a member of an object declaration inside that class. Companion objects. Even more specifically, if you declare a companion object inside of your classes, you'll be able to call its members with the same syntax as calling static methods. So companion object is definitely something we're going to learn later, maybe recently. So yeah, we should look at the objects later, but maybe not now. So we were at classes and inherent, and that's have already taken up all of our time today. So that's all we have today. Let's have a quick review because we still have 3 minutes. So today we'll talk about inheritance and how the constructors should be overridden and how the methods are overridden, and we can also override properties and derived class. Okay, so we know that we have also learned that the initialization of a derived class, it always runs the base class initialization first, then the derived logic itself, and then calling the superclass implementation. This is just like Java. We can use that super keyword and overriding rules. This is another and we also have something like the Java class name list. We're using super add class name here in Kotlin. So overriding rules, let me take a look. Open class. Oh, it's actually talking about how multiple inheritance are forced to be clarified. If you have multiple implementation inherited, you need to implement it yourself to clarify which implementation you're going to use. So abstract classes, that's just yet an introduction to abstract classes. It's just like Java again. So companion objects, we don't know a lot about this yet. But we have learned that there is no static methods in Kotlin. So I think we're going to talk about the companion objects once we have reached objects here, which we have not reached yet. So that's all for today. We have not solved any problem today, but I hope this is still a content-packed live stream for today. So that's all for today. See you tomorrow, and yeah, we're going to see you back at Learning Kotlin Live episode 21st, episode 21 tomorrow. Bye bye.